All right. In the last unit, we spent a good bit of time learning to figure out how to put together nonmetals to make covalent compounds. Like, for example, if I were to give you nitrogen and hydrogen to put together, then you go to your periodic table. I hope you have your periodic table and are using it to practice. The more you use it and put your hands on it and work with it, the better you're going to be at this sort of thing. So here's nitrogen on your main periodic table, and if I count from the left in that row, I've got 2 electrons in the S sublevel in this valence level. The highest energy level is number 2 for nitrogen. I've got 2 electrons in S and 3 electrons in P. That makes a total of 5 valence electrons. So we're going to put 1, 2, 3, 4, 5 electron dots around nitrogen. Hydrogen, on the other hand, just has 1 electron dot. It's in the first primary level, only has 1 electron in the S sublevel. And so it's going to have 1 electron dot here, okay? And then we go about sharing electrons. So before I started sharing, those would have been called electron dot formulas. We learned that in Unit 2. The sharing arrangements we learned in Unit 3, and now we're in Unit 4. We're about to start naming compounds. Okay, we did some ionic compounds already. Now we're going to learn about covalent compounds. I'm just kind of reminding you where we came from, okay, and how we got here. We also looked at how we use orbital notation to figure out how you can overlap and share orbitals. We did balloon models where we showed this actual 3-dimensional shape when you overlap or share orbitals. But right now we're not going to go back through all of that, just kind of pick up from right here. So then if I squeeze the electrons in between the symbols like this, I get a Lewis formula. So this is the sharing arrangement. This is the Lewis dot formula. And in the Lewis formula, we replace shared pairs of electrons, that should be an N, with lines. Okay? And so that's the Lewis formula. Well, the formula itself, the chemical formula, what sometimes is called a formula unit, is just NH3. Okay? 1 nitrogen and 3 hydrogens. The question is, how do we know which element to put first? We always put the element that's to the left on the periodic table first. Now, hydrogen's a little bit unusual because sometimes it belongs right here. We went through this in Unit 2. We did periodic table properties. Hydrogen best belongs here sometimes, but sometimes it best belongs here. And we're combining it with nitrogen, it best belongs here. Okay, there'll be times when it best belongs there in terms of figuring out which one you write first. But for this, we're going to write the nitrogen before the hydrogen. Now, this is a common chemical that you have to memorize and know the name of. Okay? And this is called ammonia. Okay? It's ammonia. But there is a formal naming system for this. Okay? There's a formal naming system for this. The first element, much like we did with the ionic compounds, the first element is just named what it is. Nitrogen, so a formal name. We're going to put nitrogen first, and then we're going to put hydrogen, but change the ending of the name to IDE. Okay, so this would be hydride. Well, let me put hydride over a little bit. Because with covalent names, if we have more than one element, we use prefixes to indicate how many elements there are. Okay, we didn't use prefixes for ionic compounds. We are going to use prefixes for covalent compounds. So since I have 3 hydrogens, this is trihydride. All right, so these are covalent compounds, and these are not the organic ones. We'll call this either non-organic, or we can call them physical. Okay, sometimes we call them one or the other depending on the context. All right, you've got organic compounds, you've got physical compounds, or non-organic compounds. And right now we're in the non-organic or physical compounds. Okay? All right. So the prefixes, let's list the prefixes for you. These are the prefixes you're going to have to use when you're naming covalent compounds. But before we do that, let me remind you, You can tell it's a covalent compound, usually, not every single time, but usually you can tell it's an organic compound if it's a combination of nonmetals. Okay? Covalent compounds are usually combinations of non-metals. Okay? When we were in Unit 2 and looked at periodic table properties and periodic table patterns, we went over that from this stair-step arrangement here to this side, to the upper right, those are all the nonmetals. So any combination of these elements, or a combination of these elements and hydrogen, because hydrogen best belongs here in this context. Okay? Any combination of all of these would be a covalent compound, usually. Any combination of the metals, metals are everything on this side of the stair step, metals plus nonmetals would be ionic. Okay? But hydrogen is that strange with it. Sometimes belongs here, sometimes belongs there. And later on we're going to find out it's even more strange than that, because we make acids out of hydrogen, which is not really, is sometimes ionic, sometimes covalent. It's kind of strange. Okay. So the prefixes we're going to use. Now, the prefix for one we don't use except for one chemical. There's only one chemical we use a prefix for one on, and that's carbon monoxide. Okay? But it's the only time we ever use the mono prefix, carbon monoxide. Okay? For any other chemical, if there's only one nonmetal in a covalent name, we just don't put a prefix in front of it. Okay? And then after that, then we have di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, like an octopus has 8 tentacles. Okay. Nona for 9, and deca for 10. Okay. A decade is how many years? 10 years, like deca being the prefix for 10. What is the place in Washington, D.C. where all the military, you would know that, sure, ROTC, yeah, okay. Let's see, what is a wheeled vehicle with 3 wheels called? Tricycle. See, some of this stuff you kind of already know, don't you? Okay. There used to be a game called Tetris. Nobody plays it anymore, but you're like, huh? Okay, well, some people play it. Okay. Let's see. So we said octa was 8. Octane. Gasoline has an octane rating. Is also where octa comes from. Okay. So some of these you should be familiar with. Okay. You should be familiar with di and tri. Some of you are familiar already with tetra, penta. You should be familiar with octa already and deca. So some of these you already know. You just need to relate it to this. Does that make sense? So a few of these you just got to memorize. But most of these you have some familiarity with, and you should be able to put it in place in this context. Okay. So let's say we have something like this compound here, PCl5. PCl5. Using this system now, I want you to name PCl5 on your paper. Capital P, capital C, little l, subscript 5. Remember the subscripts down here in this lower right, we went through this yesterday, are that section down here in the lower right is reserved for the number of elements. Okay?